last lesson, we learned how to determine how much product is formed in a chemical reaction when given different quantities of reactants. And so the last concept we need to learn in this unit is percent yield. Now, percent yield tells us how effective our laboratory technique was. And so there are two major terms that we need to discuss in order to understand percent yield. The first is theoretical yield. Now, theoretical yield is the amount of product that you predict should be formed using calculations. So exactly what we did in the last two sections. When you calculate, given a certain amount of reactant, how much product should be formed, that value is your theoretical yield. So while the theoretical yield is how much product should be formed based on the calculations you performed, the actual yield is what you actually were able to collect during a laboratory procedure. So the actual yield is what you actually got in the lab when you performed the experiment. The theoretical yield is what you calculated should have been produced. So to determine the percent yield, your percent yield, and I'll write it here under the first example problem, you can write it wherever you want, but the formula for it is simply your actual yield, what you actually got in the lab, divided by the theoretical yield, what you calculated should have formed. Okay? And then what we're going to do with this value is we're going to take it in order to make it a percent, and we're going to multiply it by 100%. Okay? And that's all percent yield is. Okay? So obviously, when we're doing problems and we're not in the lab, we would need to be given the actual yield. Otherwise, if we were completing a laboratory procedure, then we could determine the actual yield by performing the lab, getting the amount of product and measuring its mass, and then you can determine the theoretical yield by simply doing stoichiometry and figuring out how much product should have formed. All right? Two quick notes. First of all, if your percent yield is less than 100%, that means you were not able to collect all of the product that should have formed, meaning you have less actual yield than theoretical yield. And so probably what happened was if you were collecting a solid, some of it might have been stuck onto the container and you weren't able to collect it all. There are a number of different reasons why your percent yield might be less than 100%, and it rarely is 100%. However, if your percent yield is over 100%, which doesn't make sense because that means you actually collected more product than should have been collected, what's likely is that you have some sort of a contaminant. So that's a good way to know just how effective your laboratory technique was. All right, so let's look at two example problems here. It says if the theoretical yield of a reaction is 24.8 grams and the actual yield is 18.5 grams, what is the percent yield? So all I need to do is take my actual yield. This is what I actually got in the lab, 18.5 grams, divided by 24.8 grams, and then I'm going to take that and multiply it by 100%. And that's all there is to percent yield. And what I get, so notice 18.5, I'm going to write this answer unrounded really quickly. Okay. If you notice, 18.5 has 3 sig figs, 24.8 has 3 sig figs, so this is going to round to 1, 2, 3 sig figs. So my answer is going to be 74.6%. Okay, so not bad, not 100%, but it could be a lot worse of a percent yield. All right, let's look at the next problem. It says, consider the reaction below. When 11.2 grams of nickel sulfide react with 5.43 grams of oxygen, determine the theoretical yield of nickel oxide. All right, so the first thing I need to do is I need to balance. I've got 2 sulfurs on my reactant side, so I'm going to put a 2 here. Okay, then notice I've got 4 oxygens from the sulfur dioxide. I've got 1 from nickel oxide. So that's a total of 5 oxygens. So this is going to have to be 5 halves in front of O2 to make it 5 oxygens. So then I'm going to actually end up just multiplying everything by 2, right? Because I can't leave this as a fraction. So that's going to be a 2, that's going to be a 5, that's going to be a 2, and that's going to be a 4. Okay? So let's work on the problem now. So I'm going to write out my 2 givens. I've got 11.2 grams of nickel sulfide. Okay? And I want to convert each of these into grams of nickel oxide in order to determine my theoretical yield. Now keep in mind, my theoretical yield is what theoretically should have been produced. So this is just going to be a normal limiting reactant problem. So I'm going to get out of grams of each of my reactants and into moles. Okay, now I need to get out of moles of my reactants and into moles of nickel oxide. Okay, and the last step, because I want to know the theoretical yield, I want to get into grams now of nickel oxide for both of these. Okay, so last step, get into grams. All right, and let's get all of our conversion factors now. So nickel sulfide, grams, in order to go from grams to moles, I need to figure out the molar mass. Okay, nickel has a molar mass of 58.693, and I'm going to add to that the molar mass of sulfur, which is 32.066, but I need to multiply that by 2. So the molar mass I get is 122.825 okay, for every 1 mole. Okay. Mole to mole ratio, I need to use my coefficients. So NiO has a coefficient of 2, Ni2S has a coefficient of 2, okay. And then nickel oxide. Nickel is 58.693, okay. Oxygen is 15.999. So the molar mass of nickel oxide is 74.692. Okay, I'm going to do the same thing now, but for oxygen. So 1 mole, 15.999. However, I have 2 of them, so I'm going to multiply by 2. So the molar mass of O2 is 31.998. I'm going to use the mole to mole ratio. There's a coefficient of 2 in front of nickel oxide and a coefficient of 5 in front of oxygen. Then the molar mass of nickel oxide I already determined. Okay. So now I just have to actually plug this into my calculator. So 11.2 divided by 122.825 times 2 divided by 2 times 74.692. And I forgot to put a 1 right here. Sorry about that. And so the mass that I get, I want to have 3 sig figs for my final answer. So I get 6.81 grams of nickel oxide can be formed from the nickel sulfide that I'm given. For the oxygen, 5.43 divided by 31.998 times 2 divided by 5 times 74.692, I get 5.07 when I round to 3 sig figs. Okay? So this is, the first part of this is a limiting reactant problem. Nickel sulfide can form 6.81 grams of nickel oxide, while the oxygen I have can only form 5.07. So what that tells me is that oxygen is my limiting reactant, and to bring in a new term, my theoretical yield, what should theoretically form, is 5.07 grams of nickel oxide. Okay? However, the question notes if 4.86 grams of nickel oxide are actually formed, meaning in the lab this is my actual yield, what is the percent yield? So remember, your percent yield is going to be your actual divided by your theoretical times 100%. Okay? So my actual yield here is 4.86. Okay. My theoretical is 5.07. I'm now going to take that and multiply by 100%. So my percent yield when I round to 3 sig figs is going to be 95.9%.